Hi, in the lecture today we are going to take up a problem regarding evaluation of a limit by using a table of values. So the problem that we have in mind is the following. H of x is defined as tangent of x minus x over x cubed. We want to find the limit of this expression as x goes to 0. You remember that to evaluate limits you can either use a graph if one is provided. You can use a table of values and try to guess the limit, and the other one was using algebraic or trigonometric approaches to find the limit. Okay, we are going to pick up this example which emphasizes using a table. We are going to mention some issues regarding effective use of a calculator. Make sure that you do get the best out of your calculator, and then we are going to have some difficulties even using a calculator. We are going to talk about finite precision issues. Any calculator or any numerical device is going to have a finite precision. You can only work or display so many digits, and that's going to create a problem for us, because here when we want to take a limit we are really looking at very small numbers, and our calculator might not be able to handle that kind of a situation easily. Let's go ahead and see how to approach this problem to begin with. So here's our function. We have h of x is equal to tangent of x minus x over x cubed. The problem asks us to make a table, and we might as well go ahead just make a table. So here is some representative x values, and here is h of x that I'm trying to evaluate. We might as well just stay to the positive numbers, and we are approaching 0 as we are taking the limit. Some of the numbers you might use here are, for example, you can start at say 1 far away. You could come close. Next step, perhaps you want to take 0.5. The next one you might like to take 0.1, and then a next step 0.05, 0.01, 0.005, and so on. So here are some representative x values, and then we are going to calculate h of x. This function is not too complicated, but still effective use of a calculator is going to help us. What does it mean, effective use of a calculator? Well, usually students approach any of these formulas in a piecemeal fashion. That is, they maybe evaluate the numerator and write it on a piece of paper, evaluate denominator and write that on a piece of paper, and then go ahead, enter each of these numbers that they wrote on a paper, and try to divide them and get the number for the function in that style. Well, what's going to be the difficulty with that? The difficulty is that, well, if you're writing so many numbers down, you can always make a mistake missing some digits. Error number 2 is that when you are writing so many digits, you get tired and just keep maybe 1 or 2 digits and lose the accuracy of your answers that way. So what's the solution to this problem? The solution is to try to use the calculator efficiently, and there are some of the buttons on the calculator that the students typically do not use, and I want to push for those in this lecture. Here are buttons on the calculator that if you haven't discovered, you want to discover them now. Important functions are the buttons. The very first obvious one are just the parentheses. Mathematical expressions sometimes need to be enclosed in a parenthesis for proper interpretation. You can do the same thing on a calculator. You have a button for the left parenthesis, you can have a button for the right parenthesis, and you can employ them. Just imitate whatever you're writing while using this parenthesis. So if I want to make sure that my expression here is interpreted correctly, perhaps I need to put my numerator in a parenthesis. And then while that one is all done, I can go ahead and divide with the denominator. If the denominator was also a complicated expression, or I had some doubts about how the calculator is going to interpret what I am typing at it, I could go ahead and use a parenthesis in the denominator as well. So even though in this case that's not necessary, if it was something more more involved, for example, there was say sine of x in the denominator next to this or whatever, I could put that in a parenthesis as well. So as you're typing in, you can include your expression in a parenthesis. The next issue is that if I were to actually enter the number x every time I see it, and the number x is a complicated number, perhaps with lots of zeros, perhaps with lots of strange digits, that mere act of entry itself is going to be error prone. So what is it that's the solution here? A typical calculator has a storage button. So you have this button which might be named differently on your calculator. It might be called memory or data or something like that. You have to read the manual of your calculator to figure out which button is this button. So this is either storage or memory, excuse me. Or data. Really different styles of calculator use different terminology, and there is really no way around the issue of looking up your calculator manual and see what this button is called on your calculator. Pretty much most calculators these days do have several storage facilities on them, meaning you can have different numbers stored in different places. So on a very low-level calculator, you just have one storage place. In calculators slightly higher level, you could have say 6 different storage locations, or perhaps 99 storage locations, and so on, depending on how expensive your calculator is and how much capability it has. So some very basic calculators these days let you do the following. You can, for example, enter a number. Suppose you have a complicated number like 0.1234567 and you don't want to type this thing over and over again. After you type it once, you either press storage, and that's already going to be in the memory of your calculator, or if your calculator has actually several storage locations, excuse me, you might want to specify at which location to store this thing. So typically your calculator has might have, say, locations A, B, C, D, E, F, these 6 different locations, in which case you go and after you press the storage, you can go ahead and press that letter. So again, it all depends on your make and model. It could be the very basic calculator, just has this button, you press it, and then that already contains your number in a memory location. A more advanced calculator could allow you a large number of storage locations, and somehow you have to label this as to which one of those location it's going to occupy, in which case you need two buttons to press to get your numbers stored. Okay, let's assume that you figured out how to store a number on your calculator. How would you get it out of your calculator? Suppose you want to do something with it and you are in the middle of some other calculation, and for some reason you need to come back to that particular number. So in this case, you have a single button on your calculator that almost universally called RCL. I assume it means recall. So this is probably a recall calculator. It calls the memory for you. If you have just one memory location, that one automatically recalls it. If there are several memory locations, then you have to specify which one of those locations you want to take out again. So if you stored it in A, now you recall by pressing RCL and pressing A, and then you get your number. So perhaps you want to practice this. Go ahead and even though this number is not so complicated to enter, you want to perhaps practice once by calculating your function at x equal to 1 and see what you get. Second time around, push yourself to go ahead, use the memory button to do the same thing for you. Okay, let me go to the next page and start doing these calculations, and then we are going to make this table again on that page. So here's our function. H of x is equal to tangent of x minus x over x cubed. Question is, how do I use my calculator to calculate say h of 1? That was the very first number in our table. I have to calculate tangent of 1 minus 1 over just 1 cube. Now that is innocent enough, but as soon as you start using your calculator, it becomes an issue. Which buttons do I press and which order, and so on and so forth. So I go ahead and explain it based on some of the common calculators that are in use, and then you try to see if yours matches that. If not, you come and talk to me about it. First issue that we have to handle here is that we don't want to do the following, which is go ahead, calculate tangent of 1 on your calculator, and for example, that is going to give you 1.5557407725, etc. And then go ahead, do the next one, tangent of 1 minus 1. This is not all that bad, that you have to subtract 1 from this thing, so you're going to get 0.5574077725. In the next step, whatever we have so far, it has to be divided by 1 cube. 1 cube is not a hard calculation to do, it's just as a 1, and here you get 557407725. So that wasn't all that bad, except that after you want to do such a thing 10 times, and each of your calculation has lots of strange numbers to be used here, chances quite high that you are going to make a mistake, and if you don't make a mistake, you are going to get really tired of doing this. What I want to emphasize is that we don't want to write intermediate results. So here's a holy grail for us. We do not want to write down intermediate results. So what do I do instead? I have this fraction to deal with. I have two options. One option is to enter numbers in the calculator like this. I can press my left parentheses, then you most of your calculators allow you to enter the functions first, then type in the argument, and then subtract. It so happens to be the same number. Then you can close the parentheses. So far what you have is just the numerator. Now you want to divide, and divide, here's how you divide. Now denominator is x cubed. Most calculators have a x cubed button. If we had more stuff in the denominator, we would have opened another parentheses, in which case you had the option of opening a parenthesis. Then you want to write your x cubed. X cubed in this case is 1, and then you want to cube this thing. You typically have the cube button, so here is and then you close this. So that portion is going to be these parentheses are optional in this case. Now after you are done with all of these things, all of this calculation, you need to press the enter or equal sign for the calculator to know that you're all done and you want to get the answer. Okay, perhaps you want to practice this sequence a few times to make sure that you understood how to do this thing. Okay, so we are still not using the memory button. We are using the calculator straightforward with inputting our x value every time we need it, and it's just that we are stringing everything along one line to get the answer. So you really need to translate this thing in your head to a sequence of actions on your calculator that will imitate this function fully, and all that is left for you to do is to type in your x. So here's where your x is calculated or entered. Once, twice, 3 times you have to enter that particular number. Now just the very fact that we have to enter the same thing so many times, that's going to be a tiring issue, and that is what the storage button in your calculator is going to come in and do for you. So on the next page I'll tell you how to handle this with the storage button. So we go ahead. Suppose again we have let me remind ourselves that our function was h was a tangent of x minus x over x cubed. Let's for the sake of discussion say that we want to evaluate this function at x is equal to 0.5. So question is find h if x is 0.5 using the memory feature of the calculator. So you go ahead and type in the number that you want to use, and you are going to type this thing just once. So you type in the number you want to use Then you are going to type in your storage button. It's either just that or slightly fancier, couple of dollars more expensive calculator. You have storage, and perhaps you choose a letter. Say there is a button there which has A either written on it or next to it. For example, on my calculator I have a power button, and on top of it is this A. By now I have 0.5 in the memory of the calculator. Now I do exactly what I did before, except that every time I want to refer to X, I have to recall it. So I start numerator has to be separated from denominator, so I press the parenthesis button. Then I have to press the tangent function. So here's another function. I might as well color it differently. So tangent. Now we want to say tangent of X. How do we say tangent of X? We are going to say recall if your calculator is of this type. Recall by itself is going to do it. If it is of this type, then you have to say recall that particular memory. So it says recall, say A. Then we go on. We have say we have to subtract, so we have a subtraction button. Next we are calculating just X by itself. To do that, we have to go through this dance again. We have to calculate that recall A. Okay, by now we are here. Numerator is all done. I better close my parentheses. Now I want to divide, so I'm done with the numerator. Denominator doesn't really need a parenthesis here, but just to emphasize good writing style, let's say it was complicated and I put it in a parenthesis, so we practice that too. Now we have to divide, so here's divide. And then you go through this thing again. So I continue on the next line. You are opening a parenthesis. You're referring to X again, so that referral every time is done the same way. Notice you just press two buttons or just one button as opposed to entering a whole number. So if your number was 10 digits long, you appreciate how much better this one is going to be. Now you have to figure out if your calculator does cube or you have to use some other button to perform that cubing operation. So like my calculator has a cube button. Now I'm all done with the denominator. Then all that is left to do is what is this in quantity is supposed to be equal to. So we typed the number, we put it in storage by one of these two styles. Then we came and typed this whole sequence. So I typed all this sequence that you see here to evaluate my function. One more round. If your calculator has this simple storage button, then you don't need this letter to specify your storage location. Okay, you go ahead and do this thing, and let's see if they all agree on what numbers we are going to get. So here, very first one, tangent of 1 minus 1 over 1 cube. Go ahead and do this thing and see you are going to get 5,574. The next one, tangent of 0.5 minus 0.5 over 0.5 cube. and make sure that you get 3704. I forgot to mention one thing. I better mention that before we go further on. All trig functions in calculus have to be calculated using the radian measure. So let me just specify that before anybody is overly distressed. Why do their numbers don't agree with this thing at all? All trig functions in calculus are to use radian measure. Okay, so that's opening another can of worm here, but on your calculator there is always a button called DRG. As you press this button on some corner of your calculator, you are going to see one of these words going to show up, degree or radian or grad. As you press this button, it's going to jump from one to the next, from that one and back to the first one, and just you toggle between these three choices. You want your calculator always to show the radian whenever you're doing, because of facts that we are going to see shortly. Okay, let me continue with some other numbers that we are to evaluate for this function. Tangent of 0.1 minus 0.1 or 0.1 cubed. Okay, each one of these things you practice and improve your speed on how fast you can enter items on the calculator, and essentially show your comprehension of the formula that you see here. Next one that you are supposed to do is 0.05. So we are making a table of these type of numbers. They are numbers that are approaching 0, and here we get 0.33366. We see some pattern emerging here. 3 showed up, now there are 2 of them, now there are 3 of them. Let's see if this pattern holds. We go one more round. We have tangent of 0.1 minus 0.01 over 0.01 cube, and there we get the pattern is still holding. I might as well continue on this page, so let me go ahead and next we have tangent of, what's that, 0.005 minus 005 over 005 cubed. You calculate that, you get 3333366. Now we got 5 of them. So we see that this string of 3 is getting longer and longer, and we are gonna live under impression that if we keep doing this, more 3 is gonna show up. Now I invite you to try the following. Take your x to be a tiny number. Okay, we would suspect to see a longer string of 3s here. You try that. Notice if you were to enter this thing by hand, how error prone that's going to be. If you mistake how many zeros you are entering, you'll be in trouble. But if you use the memory button, that's not going to happen. You are always entering same number everywhere. You do this and you get here, so surprise, you get 0.333. Most calculators, that's all they're going to show. You push the issue one more level. It says, okay, let me see what's going on here. I go and take this number 10 to the power of minus 7, a tiny number here, and I go ahead and calculate the same. Okay, so 1 over a million, and then you go calculate this thing and you see 0. Not only you don't see the number of 3's increasing, you see all of them all of a sudden disappear. And thereafter, if you take any smaller x, the answer sticks at 0, doesn't budge or move anywhere. So what are we to make of this? Well, typically we don't dig that deep. In simple problems, we do a few of these things, and before our patience is over, we declare that we have the answer. That is, by looking at the following observation from here to here, perhaps, or maybe coming up and including that one as well, we are ready to declare that the limit of tangent of x minus x over x as x approaches 0, it is just a string of 3's. And that's a correct answer. That's just 1/3. That's a theoretically correct answer. That the answer is just 1/3. The issue is, what are we to make of this situation? What's going on here? That kind of a situation can show up in our evaluations of more complicated problems, perhaps, or even here, and it could throw us off. Perhaps we are going to go declare the root, the limit to be 0. Perhaps we are going to declare the root is exact 0.333 and no more of that. What's going on here? And that's the issue that we are going to talk about next. So here is correct final answer for this problem, but we are hoping to get a little bit more understanding now. The issue is just about every one of these calculators that you use have a finite precision limitation. Okay, this limitation, I better use the word shortcoming perhaps instead of limitation, so that you don't think that I'm talking about limits here. The issue is that in the memory of your calculator, there is just so much room for writing down a number. It does not go on forever. For example, the calculator is going to cut your numbers off perhaps after 16 decimal places or 12 decimal places or something like that. So it is cut at some place. Now when you are working with numbers, the numbers themselves, the decimal expansion of it goes all the way to infinity, but to be practical, you have to cut it off somewhere. And then to add insult to injury, what is shown on display is even shorter than that. Usually half of this is shown on the display. So here is your display, and up to here is what is residing inside the memory of the calculator. And you really want this whole thing. Your number typically goes on forever, the actual number. Now let's see what happens if you are dealing with say tangent of x minus x over x cubed. This is the piece that you perform first in your numerator. Suppose tangent of x, the true value of it that you calculate, can start from here, and you have a bunch of digits. They all go all the way from the first one to the last one to infinity. They are all there. And then you write the x also. X itself could have infinitely many digits. Now it could happen that both of these share the same set of digits from here to here. That is, their difference could show up further down the road. If that is the case, when you do the subtraction, as soon as the difference is the same up to the location that is kept in the memory, the calculator, when it subtracts them, is going to declare the result to be 0. Even though they are different from each other down here, but calculator does not see these numbers. It just sees the answer all the way up to here. It performs the subtraction and declares the numerator to be 0. And then you go ahead and divide by denominator, but since the numerator was 0, that's not going to make a dent, and you get your answer to be 0. Those kind of problems do occur in calculations, and engineers have to always watch out for them. Subtractions are always a dangerous operation to be performed, exactly for this reason. When the two numbers come very close to each other, the result of subtraction causes a loss of significant digits. The issue is important enough that has a name for itself. It is called catastrophic cancellation. So we cannot go through the issue too deeply right now. Perhaps something that you are going to encounter in a year or two in more advanced math classes, where these type of issues are going to be discussed, or perhaps in your computer class you are going to see more of this. We have to always keep in mind that when we use a calculator, what is coming out of the calculator is not necessarily indication of a correct answer. It could be more indication of the limitation of the calculator than anything else. So for that reason, we have to be always extra careful with announcing the result of our calculation as to be an exact answer, and that opens a room for intelligent human being using them. Okay, you go ahead and do several other exercises from this section, and if you have other questions, you can always let me know. Good luck and God bless.